Alrighty, so this video is going to take you through some of the different, an explanation of some of the different pieces of your Unit 2 project that you're going to be starting and working on here over the next week or so. So what I'm about to show you, and it says it in yellow right here across the top, this is an example project that is only intended to show you what it should look like, okay? I've changed the numbers, so don't think that you can just copy and paste stuff and that it'll work for your project because your numbers will be wrong, okay? All of the numbers have been changed on all of the different things throughout here, but I wanted to give you guys an example of what it would look like and kind of the things that I'm looking for throughout the different portions of this project. So, problem description. You've been hired by the City of Mission to develop a new retail and/or restaurant district at the site of the old Mission Mall, which is by the Wendy's down there at Johnson Drive and Row, okay, just right down the street from north here. They hope will compete with the popularity of the Country Club Plaza and the Legends, or Oak Park Mall or something like that, okay? The City Council would like you to use linear programming to determine what combination and what location of restaurants and retail shops will generate the most profit. So you have a whole bunch of different things that you're going to have to find here, all right? And I'll take you through how to find that stuff here in just a second, okay? Well, not how to do it, but I'll show you what it should look like and how you should do it, okay? So here's a list of all the different things that you need to be able to do. And then we're going to get to this part right here, which is the three portions of your project. And we'll get to how this is going to be graded here in just a second, okay? The math portion is this Google document that I'm showing you right here, okay? This Google Doc has a link on Canvas. You'll open that Google Doc. You will make a copy of that Google Doc, and you'll share it with me. And then you'll submit the link to that Google Doc by next Thursday, October 29th. So you have to submit this document, so you can either submit the link to the Google Doc or you can download it as a PDF and just submit the file that way. Either way is fine. Typed answers for the variables, constraints, objective function, a screenshot of your Desmos graph of the constraints with all the vertices identified, the table, which I'm going to show you what all of this stuff looks like here in just a second. Also have to have your final answer with the number of restaurants, number of retail stores, and the total profit. Okay. You'll submit this document to the file submission assignment on Canvas by next Thursday, October 29th. You also have a presentation portion that's due the next day after that. So if you're waiting until the last minute, you're probably going to run out of time here. Okay? So on Friday, October 30th, you will present your solution in a video discussing your unique constraint and describing what you had differently due to your unique constraint and your final answer. Okay? These items should be shown in a presentation aid, like a Google Slides, a Prezi, or something like that, in your video, while you, or if you're in a small group, everybody in your group explains what's in that presentation and explains what you did, thinking of it being that that video is going to the Mission City Council, okay? And so you're trying to pitch your idea for them to choose your idea. Brainstorm and explain briefly what stores and restaurants you would fill the vacant lot with if you got to decide. So you need to make sure that your video is about 2 to 4 minutes long, and you're going to post a link to that video in a discussion forum by next Friday the 30th, okay? What we will then do with that discussion forum is you'll post a link to your video, and then you have to watch the video of at least 2 other people or 2 other groups, depending on who, what it is, and post a response, okay? Your responses. So you have to post your video, you have to post a link to your video by Friday, October 30th, and then you have to have your responses done by that following Tuesday, November 4th. So once you've posted a link to your video in the discussion forum, watch the video of 2 other people and post a response. Your response has to include 2 things you thought they did well or that were interesting, which we call glows, and 1 thing that they could improve on and something they could grow with in order to receive full credit for that, okay? Here is your grading rubric on the second page of this Google Doc here, okay? The math portion that's due next Thursday is worth 30 points out of a total of 50. So if you look down here, project is out of 50 points, will be scored as a test grade. So the math part of this is a large majority of the grade, okay? That doesn't mean that you don't have to do the presentation or the discussion parts because you might miss points on the math portion, but a large majority of that overall grade does come from the math stuff, okay? So all these different things as you go through in your math portion here, Just make sure that you hit all of these different things. If you hit all of these different things and they're correct, you get full credit. You're already off to 30 points out of 50. Okay? All the different points for your presentation portion, which is due next Friday, are listed here. You have to make sure that you explain what your unique constraint means and how it made your answer different. You have to make sure that you have, Google Slides, PowerPoint, Prezi, whatever, and make a video with that. Audio clear and volume at an appropriate level. Solution is communicated in an academic manner, not just, we went with 4 restaurants and 6 stores. Tell me what it means, right? Proposed restaurants and retail shops are mentioned. Aim for 2 to 4 minutes so that it's of sufficient length. And then the other part of that is if you are working in a group, every member of your group has to speak at some point during the video. So whether that means you edit different clips of the video together, that's totally up to you guys. Okay. So then the discussion portion is only 5 points out of 50, but that is an important 5 points, obviously, right? You have to have your link posted before the due date. That's 2 points out of 5. And then responding to 2 other classmates' presentations is 3 points. So total of 50 points out of a test grade. Let's go ahead and take a look at what this is going to look like. Again, this is only an example. I changed the numbers, so make sure that you put your name at the top. Question number 1, determine the area of the lot. So I gave you the address of the lot right here. We're going to use the Google Maps measurement tool, and I'm actually going to show you how to use that right now. So the first thing that you're going to do, you might not be able to see this, you're going to go to maps.google.com. So you're going to this website right here, maps.google.com. And of course, my internet's going to take forever now. All right. So then, once Google Maps comes up, you're going to search for the address, which is 4901 Johnson Drive. And it should take you pretty much right to it. Okay? And so once this comes up a little bit, I'm going to collapse this little side panel here. Normally more of the streets and stuff, there we go. Okay? So 4901 Johnson Drive is technically the corner of it right here, but this is Johnson Drive that runs right through here. This is that Wendy's that's down there by Johnson Drive and Shawnee Mission Parkway. This yellow one or orange one is Shawnee Mission Parkway right here. The one that goes up and down through here is Row. So we're looking at this vacant lot that's kind of right here in between Johnson Drive, Shawnee Mission Parkway, Row, and that street that Wendy's is on. Okay, so I'm going to zoom in just a hair here so that we can get a good idea of what this looks like. And so to do the measurement tool and figure out how much space there is available, I'm going to start in a corner and I'm going to click to drop a little point like that. Okay, and so that drops a point kind of right there in the corner. Then I'm going to do a right click, which means you can either click on the right side of your touchpad or 2 fingers at the same time, and it'll bring up this little menu here. We want the last option where it says measure distance. And then I'm just going to start putting more points just along the edge and along the outside of this. So it kind of goes straight till right here, and then I'm just going to keep going and putting points along the outside. That goes all the way over to here now. Make sure you don't cross the street because we don't want our restaurant district to take over a street, right? And so we're gonna keep going. Then once you get back, and so to end it and for it to tell you how much space there is, we're gonna click on the point that we started at. And then you'll notice down here, in which you probably can't see it because it's off of the screen, it says the measure distance thing. It's going to give you a total area and it's going to give you a total distance, okay? So whatever your total area is, right now mine says 755,189 square feet or feet squared. So I would probably round that to just have zeros on the end of it, and I would round that to be 755,000. You might get a slightly different number than me. I believe on the thing, it says that your measurement should be somewhere between 500 and 8,000 square feet. So as long as it's somewhere in between there, whatever you get is fine. If you wanted to take a screenshot of this whole thing and include it in your math portion and include it in your presentation, that might not be a bad idea. But I got 755,000 square feet, so there's, boom, the first part. And on the grading rubric, hey, look, I gave the usable area of the lot, so I'm already 3 points out of 30 on the math part. Good stuff, right? So determine the area of the lot, Google Maps measurement tool. I got 755,000. Your number will be slightly different. That's okay. Moving on to question 2. Consider the following information on retail shops and restaurants. I changed the numbers. Restaurants require 35,000 square feet of space. Retail stores require 65,000 square feet of space. And remember, there is a limited amount of space you can use based on what we just got. Profit, 20,000 per month for restaurants, 40,000 per month for retail shops. Okay. So the second thing on the grading rubric that you have to cover for this is to determine the variables, X and Y. So I put X as the number of restaurants, Y as the number of retail stores. I wrote my objective function, which is to maximize profit. And the way that we're getting profit is 20,000 per restaurant, so 20,000 X, and 40,000 per retail shop, so 20,000 X plus 40,000 Y. And we have 3 different constraints here, right? We have those 2 that we put every single time because we can't have a negative number of retail shops or restaurants or whatever, okay? And then we have the constraint of the space, okay? Restaurants take 35,000, retail shops take 65,000, so 35,000X plus 65,000Y has to be less than or equal to the amount of space we have, which for mine was 755,000. So your last constraint there is going to look a little bit different based on the information that's given to you up here and based on what you got in number 1. Okay? So then the third step, or I guess it's not technically number 3, but it says in sort of italics here, you will now be given an additional unique constraint. See Mr. Morris for your additional constraint. Once you have finished writing all the other constraints, write it below and create an inequality for it. So once you have finished numbers 1 and 2, if you want me to check what you have on numbers 1 and 2 to make sure that you're on the right track, feel free to do that. Otherwise, come on my WebEx. You can come during seminar. You can come during class. I guess you guys are going to be in person starting next week. So you can ask me in class for your unique constraint. You can send me an email and say, I'm ready for my unique constraint now, and I'll give you one, okay? So the one that I'm using, my unique constraint is there must be at least 2 restaurants built on the lot. So I changed that into a 4th constraint or a 4th inequality where X has to be greater than or equal to 2, okay? So then we go to that process of linear programming like we've been doing the last couple days. Use Desmos to graph your constraints, insert a screenshot of the graph below. And so I went ahead and determined the feasible region. I had this little triangular area right here. And so I had 3 different vertices, and I'm typing those vertices out underneath it. So 2, 0, 2, 10.538. Notice that it says up top here, if you have decimals, round down to the lowest number. Since it's going to be a maximum, if you go above it, it's either going to be going to be more space than you have available. So always round when you have decimals and round it down, okay? So I'm using 2, 0, 2, 10 since I'm rounding that down, and then this guy over here, 21.571, 0, I'm rounding to 21, 0. So once I identify those vertices, I'm plugging them in to that objective function that I made earlier, and we have 3 different options here to pick from. And what I notice here is that this guy in the middle, the 210, is the one, is the one that gives me the most amount of profit at 440,000. So my final answer in context, there should be 2 restaurants and 10 retail stores built on the lot. Oh, that should say 440,000, not 420, whoops. So there should be 2 restaurants and 10 retail stores, and I can't spell either. Man, this is great. I'm glad I did this. Built on the lot to maximize profit, $440,000 a month. Step number 4. What shops or restaurants do you intend to put there? So I listed my 2 restaurants. I'm putting Whataburger and Cinzetti's. I listed my 10 retail stores. You can read them through there. This part down here is totally optional, but is definitely something that will help for your presentation portion when you're trying to convince the city of Mission to pick your project, right? I have laid out exactly what I have going where. We got Whataburger right on the corner here to kind of draw people in. We got Trader Joe's right along Johnson Drive here, hopefully kind of bringing people in. And then we have a whole bunch of other stuff here, right? We're putting some of the clothing stores and then the Cinzetti's on the backside here right up against Shawnee Mission Parkway, kind of get some good advertising there. Those are all good things. This is very convincing to a city council of why you should pick your project. Okay, so don't forget, this is an example, so you can't copy and paste my stuff. It's not going to work out. Your stuff will be totally different. All of your numbers will be different, and that's okay. You're not going to get the same answer as me in terms of number of restaurants and retail stores. You're not going to get the same amount of profit as me. That's fine. No big deal. Okay? So now I'm going to go through and I'm going to show you a very, very quick, well, not very quick, but I'm going to give you an example of what a presentation portion would look like here. Okay? So let me pull up my presentation here. The new and improved Mission Mall. So I'm pitching this to the Mission City Council here, so I want to make sure that I'm very convincing and that they leave that presentation wanting to pick my idea over others that may be presenting their ideas as well. So the goal of this project was to construct a mall in Mission, Kansas to compete with the popularity of other popular malls around it. By using linear programming and algebra, I believe I found a solution to this problem which will be extremely profitable to the city of Mission. So the location, the new mall will be at the exact location of the previous Mission Mall. And so I inserted my screenshot of how I did how I measured the lot, and I got 755,000 square feet there, okay? The lot is approximately 755,000 square feet, which should be plenty of space for a good variety of retail stores and restaurants. The location is excellent between Johnson Drive and Shawnee Mission Parkway, right there along Row. Lots of traffic going along both streets. So in order to figure out what we were going to put there, we had a number of limitations, including the available space and some preferences by the city council. Okay, and so we listed out there. The X's are representing the number of restaurants. The Y's are representing the number of retail stores. So the first two constraints are just algebraically to say that there cannot be a negative number of retail stores or restaurants. So we said that X and Y both had to be greater than or equal to 0. Okay. Our third constraint or limitation was that the total space that we have available is 755,000 square feet. Each restaurant requires 35,000 square feet, and each retail shop requires 65,000. So we turned that into this inequality here. Don't bore the city council with your math stuff, but you do need to present it. And then constraint number 4. So the unique constraint given to us by the city was that they wanted at least 2 restaurants to be included, and that's not the right constraint underneath there, so I need to change that. That should say X is greater than or equal to 2. So the unique limitation given by the city of Mission was there had to be at least 2 restaurants, okay? This is unique, and so here's why I'm explaining why this is different. Retail stores make more profit than restaurants, so this limited the number of retail stores because it's taking up space on the lot, which therefore limits the amount of profit that we can make. But what we are thinking here is that by including restaurants in this space, this could encourage patrons to spend more time within that district shopping as they now have a place close by to eat. And then obviously having Whataburger could be a chance to have a Patrick Mahomes sighting. So that could be good for popularity of that mall and shopping space as well. Based on the graph, there were 3 vertices, and so we checked all 3 of them. The most profitable point was that guy right there, which would be 2 restaurants and 10 retail stores at $440,000 per month. This provides better utilization of the space rather than just 2 restaurants, which would be the 2-0, and provides a better chance at being successful by combining restaurants and retail shops rather than just having 21 restaurants. So we think that not only is this the most profitable solution, but it's also better for diversity because we're getting a lot more different types of things in there and hoping that we can attract more people rather than just having a bunch of restaurants, right? So then I put in there the potential layout. Here's the restaurants that we have. We've got Whataburger right on the corner. Senzetti's backing up right there on Shawnee Mission Parkway. And you can kind of go through and explain why you put things where. Again, this part where you're explaining what they are is optional, but make sure that you include what you're putting there, okay? Trader Joe's, the closest one is over on the Missouri side. There's not one in Johnson County right now. Boom, easy. GameStop, there's a GameStop over in Merriam, but this would service both the Mission and Roland Park and kind of western Kansas City, Missouri area. Barnes & Noble, there's not a ton of them around. Who doesn't love good books, right? Hardware store, Nike outlet. You're either going to Oak Park Mall or the Legends to get a Nike outlet. So this is kind of putting one right in between those two. You can kind of go through and explain all of those from there. So your video, again, should be about 2 to 4 minutes. You need to make sure that you have a quality presentation aid with all of those different pieces in it, right? So if you have any questions about things on this project, make sure that you ask me. Hopefully this explained a little bit about the stuff. So the things that if you were to make yourself a list of things, I would start with this grading rubric right here, okay? Get your math portion done first because that's due next Thursday. Make sure that you can check off every single one of these things, okay? Then start working on your presentation. Make your presentation aid first, and then figure out how you're going to explain things in the video. Make sure that you can get it between 2 and 4 minutes. You don't want it to be super long, but you don't want it to be super short either. And then record your video once you have all of that ready. And then once you record your video, post the link in that discussion forum. And then once you get other people's links in there, you can start responding and find at least 2 different classmates to respond to. So if you have any questions, let me know. This is kind of your roadmap of how you're going to do things. Start with the math portion, check things off. Once you're done with all of that, move on to the presentation portion after that.